But right now let's move on to the substring, and I'm gonna move down here and then say another useful character function is um, substring. It takes 3 arguments. String, start, and stop. So here's a note to myself about the substring function, which will make a little bit more sense to you once we use it. So what substring does is it gives us part of an existing string. And so the example in the book is this substring string vac start equals 2, stop equals 4. Okay, so what's this going to do? What it's going to do is it's going to take every element of string vac, and it's going to give me the section from the second character to the fourth character. So it's going to give me EAR from pear, PPL from apple, and INE from pineapple. And so right here we're doing the substring function on a whole vector, but we can also do it just on an individual word. We can do, so I'll show you a couple of ways of doing this. So one way is we just want one element of string vac. So this is just going to be pair. And we actually don't even need to say start equals and stop equals. Our knows that that the second argument is the start and that the third argument is the stop. So see here we just get ear. And we can also put in our own word. Substring, we have to use quotation marks. Science, and let's say we want 3 to 6. And that works as well. Okay, so then we can write a note to ourselves that the nchar function tells us how many characters are in a string. So the example from the book So what's going on here? We've passed the string vector to the nchar function, and what we get is a vector with 3 elements, and the first element is the number of characters in the first element of string vac, the second element is the number of characters in the second element of string vac, and the third element is the number of characters in the third element of string vac. So then we can use this to get the end of a word. So let's say we want for each of these fruits, we want from the third character to the end of the word. So we would do that by doing substring. So the first argument is string vac. The second argument is where we want to start, and the third argument is where we want to stop. So what we're getting here is a different number of characters for each element of our vector. Okay, the last character function we're going to talk about is grep. And the grep function is really cool. Because it identifies patterns in strings. So here's an example. Okay, so we have our string vector with pear, apple, and pineapple. And let's say we want to know which of the elements of that vector contain the word apple. So the way that we're going to do this is and say grep pattern equals apple, and the vector is string vec. So actually in the book they say x equals string vec. So this returns a vector of 2 elements, and it tells us that the elements of string vec that contain the word apple are the second and third elements. Now, just to show you some shortcuts, you actually don't need pattern equals and you don't need x equals. So R knows that the grep function, that the first argument is the text, the string that you're searching for, and the second one is where you are searching for it. So we get the same output here. And so with a vector, we get the elements of the vector that contain the text apple. If we were to do it just with a word, so let's say we want to know if the word apple is in the string pineapple, it's going to give us a 1, which tells us that the pineapple string does contain the word apple. And remember, this is because R is treating pineapple as a string vector or character vector with 1 element. So it's telling us that that first element does contain the word apple. Okay, so what can we do once we know which elements of string vec contain the word apple? Well, once we know that, then we can return those words. So if we want to get a vector only of the fruits that contain the word apple, we can do that by saying string vec, and we're going to use the square brackets because we're going to subset the string vector. And what we want is the elements that contain apple. So that's grep apple string vec. And as you'll see here, I kind of skipped a step from the example, but we get the same results. And this is kind of the same principle that we were talking about in the previous video with the logical index. So we can skip the step of actually creating a separate index vector.